Hey everyone, welcome back to Knowledge on Ears, and today we're going to be starting off with a quick experiment. Here we have the Arduino Uno R3, and we also have a servo motor. So this servo motor has 3 cables. It has power, ground, and the signal. So now we're going to plug it in and run this program that we have, and we discuss the program at the end. So I've plugged it in now, and look at the program. So the servo motor is moving. It's moving in 90-degree increments, and then it's restarting. So you can see how it's connected to this arm. It has an arm that moves. So that's how it works, and now we'll just dive straight into the video and explore more about servo motors. Hello everyone, and welcome back to Knowledge on Ears. Today we're going to be talking about what are servo motors. Today's video is going to be divided into 3 groups: the experiment, which we already did, the theory about the servo motor, and a real-life practical program that you can write for it. But first, what are servo motors? This is a servo motor, and it's a micro servo motor. It has less torque, and we'll talk about torque soon. But this is a regular servo motor. But how do servo motors even work? What are they? Well, really, they are used for robotics. Very, very often you'll see them in robotics. And they're used for precision control. We have angles on a servo motor, which is why we can be very precise with them. We use them for stuff like toy cars, for instance. Or, most importantly, you'll see them being used a lot in robotic arms and hands and stuff like that. They're used very often. But in a servo motor, we have a DC motor. And in future videos, we'll make a video about more in-depth for DC motors. But what are DC motors, first of all? Just like every other motor in the world, DC motors convert electrical energy to mechanical energy. So in this case, in motors, the mechanical energy would be rotation. So DC motors, how they work is that they take in a DC signal, they create an electromagnet, which is called the rotor, and then there's a stator, which is stationary field magnet. And the rotor and stator have this attraction and repelling going on, which is what creates this mechanical movement, the rotation. But how do servo motors really move? Because this video is about servo motors. So over here, before we dive straight into the full background of servo motors, there's 2 types of servo motors: continuous and positional. Continuous servo motors is when they move to 360 degrees. The servo motors move in a full circle. Positional motors is the one most commonly used, and they move only to 180 degrees. And we're going to be talking about this in this video. The reason servo motors are so cool is because they have angles. You can move it just an angle difference, and it makes it so precise. You can change it so much, and you can measure it by angles. So how do servo motors actually move though? What do we have to do? There's a very fundamental concept when you're learning servo motors, and that is PWM, which stands for pulse width modulation. And what that is, it's just a DC signal. It's a type of DC signal, which we know what DC signals are. And it has 2 states, high and low, on or off, just like every other DC signal. But the difference is that the length of this pulse right here, this part, is what determines where the servo motor moves, what direction it moves, how it moves. So, wider pulses, like ones like that, move closer to 180 degrees, while shorter pulses like that move closer to 0 degrees. It's that simple. Any position in between will move in between. So if you move it right in the middle, it'll move to 90 degrees. A neutral position is a term in servo motors where what the definition is that it'll move the same amount in both directions. So 90 degrees in a servo motor is the neutral position because it can move 90 degrees to 180, or it can move 90 degrees to 0. So how do you actually measure this though? In a full signal, in a full cycle of a pulse with modulation, this is how a full cycle goes. So you go up and you go down. This is one full cycle, up and down. That's a cycle. And generally, typically, this cycle will be 20 milliseconds. Now, each of these, if we look at this chart over here, if a full cycle is 20 milliseconds, we have a table here. So how much we have to move it to get to 0 degrees, 90 degrees, 180. So to get to 0 degrees, we have to move it 1 millisecond up. So that would mean if we have a full duration of 20 milliseconds, which is one cycle, we'd have to move it up for 1 millisecond, and the rest, 19 milliseconds, it would be off. There would be no voltage. For 90, we'd have to move it up for 1.5 milliseconds, a little bit bigger. And for the rest, it would be off. For 180 degrees, we would have to move it up for 2 milliseconds, a little bit bigger than that, but for 18 milliseconds, it would be off. In all of these, this is still all 20 milliseconds, but it's just different varying lengths, as you can see, different widths, which is why it's called pulse width modulation. Duty cycle is another term that we use, which is just a measurement. It's like a percentage of this when it's on. So, out of 20 milliseconds, if it's on for 1, then that's 5% of the total cycle. Out of 20, if it's on for 1.5, that's 7.5. Out of 20, if it's on for 2, that is 10%. So that's very simple. Now, we're going to look at a more complicated part, which is the parts of a servo motor. We have a few very important parts over here. This is something known as a DC motor. Sorry. This is a DC motor. And we already talked a little bit about DC motors. This right here is a DC motor. Sorry if this drawing is a little bit hard to see. I kind of drew it. But this is a DC motor, and this is the part that rotates and moves this gear train, this output. You may just think that a servo motor is the same thing as a DC motor because they both have a DC motor in it. But that's wrong. When voltage is supplied to a DC motor, it will instantly just start moving. Instantly. You just give voltage to these signal pins, start moving. But a servo motor does not work like that. When you give voltage to a servo motor, it will not start moving. A servo motor needs an external signal from something like a controller, like an Arduino or Raspberry Pi. It needs the signal, it needs the Arduino to tell it where to go, the pulse. And then that's only when the servo motor will start to move. Right here, we have a gear train. This part right here. And this is just a bunch of gears connected to the DC motor. And what it does, it converts a high speed, low torque right here to a high torque and low speed. So low speed, high torque, low speed to low speed, high torque. There we go. Now, that's the gear train, simple. Over here, we have a circuit board. And this is like the brains of this servo motor. Circuit board receives a PWM signal, and then it instructs the motor. So without the circuit board passing along what to do, the DC motor wouldn't move at all. It's also connected to the potentiometer, all right? So when the potentiometer, this part right here, when the gear train moves, right, the potentiometer also is forced to move. And it's like a variable resistor. So it has a role in feedback. When it gets turned by this output gear right here, when it gets turned, then the resistance of this potentiometer, because it's a variable resistor, it changes. And then the circuit board reads this feedback to understand the position of the output, to understand what's going on here, and to see if it's in the right place. So the potentiometer helps the circuit board know their position, where they are, what's going on. So different types of servo motors provide different torques. Over here, I provided a picture of different servo motors. Bigger servo motors need more power, more voltage to actually control them. Smaller servo motors like this one need less because they don't need as much torque. These are used for smaller applications. So to measure torque, we use something called kilogram centimeters. And what it is, it technically just means if it's 1 kilogram per centimeter, that means it can carry a kilogram of weight or mass a centimeter away from the shaft. So it's very simple. Now we're going to look at the real life program that you can write. Let's see you there. Hey everyone, now we're back here to the program. So this is a basic servo motor program that we've created right here. And how it works is we have right here, we're defining a servo object. Then we're attaching it to pin 9 right here on our Arduino board. Now this is a loop. This is the main part of our program. And what happens is my servo.write means that we're sending pulse width modulation signals down. We're writing it into the circuit board that we talked about. So as we talked about earlier, we have 20 milliseconds of a full cycle. So all these different numbers right here, 0, 90, 180, they're all just different pulses, pulse widths, right? So that's very simple. Here to the right, you can see how this program actually works. It's very cool. It goes 0, 90, 180, 90, 0, 90, 180, 90, 0. So I hope you enjoyed this video. Thank you so much for listening. I hope you liked learning about servo motors. See you all later. Bye.